Here we are on the Algebra 1 Illustrative Mathematics Lesson 1 practice problems. This is on page 136 of your student workbook. And we just started talking about functions in this unit. Lesson 1 practice problem starts with number 1. The relationship between the amount of time a car is parked in hours and the cost of parking in dollars can be described with a function. It is asking to identify the independent, and the dependent variables. So what do you think? The amount of time that the car is parked is the independent, but the cost of parking depends on how much you're parking. So if that's what you were thinking, you got it. That's the amount of hours that you're parked. And the dependent is the cost, because that's the one that changes when you park for longer. Describe the function with a sentence of the form, blank is a function of blank. What do you think? The cost or parking cost is a function of the amount of time. Suppose it costs $3 per hour to park with a maximum cost of $12. Sketch a possible graph of this function. So along the bottom, let's just do the time in hours. And then along the side, and that's because we want to be able to get up to a cost of 12. And so along the bottom, is our time, and along the side is the cost in dollars. And so when something is the dependent variable, like which axis does that go on? And when something is the independent variable, which one does that go on? You want to kind of keep track of that. So sketch the possible function. Let's go put in, suppose it's $3 per hour to park. And so for every hour that passes, we're going to go up 3, 6, 9. But once you hit 4 hours, it just flattens out at 12. And so as this is going up, then the cost doesn't change at that $12 mark. It never goes up. How'd you do? Identify one point on the graph and explain its meaning. So literally you can pick any point like the one I'm choosing. For example, 3.9 means that it costs $9 to park for 3 hours. Okay, but pick any other point and you get the point. Okay, number 2 is asking us about a little burger menu here, and they're just looking for this general idea of whether it's a function or not. And so we know that something is a function if for every input, there's only one output. And so let's take a peek here. If the price of the different burgers are shown on this sign, based on the information on the menu, is the price of a burger a function of the number of patties? So 1 patty, price, 2 patties, price, 2 patties, another price, 4 patties here. So if we were doing a little input-output table, we would say 1 patty has this, 2 patties has this, but 2 patties also has this. And so for every input, there can only be one output, but ours has 2 outputs. 2 patties has 2 different prices. And so is this a function of the number of patties? No, because there are 2 possible prices for the patties, it means there's 2 outputs for the same input. Okay, write that up along your own lines, along your own words, and that's perfect. All right, the distance a person walks in kilometers is a function of time in minutes since the walk begins. Select all the statements that are true. So notice, first of all, that time is in minutes. Notice that distances is in kilometers. So is distance the input or is time the input? Well, if distance is a function of time, we're going to be looking like d of t, where time is the input. But be careful, both B and C say that time of day is the input or time since the person starts walking is the input. Which one do you think applies? And it's not distance. You got it. It is C. Time since the person starts walking is the input. Then we also would select all that are true. So D says that T represents the input. Yes. D is not the input. It's the output. And the input is not measured. Yes, it is. It's measured in minutes. So that one's not true. The input is measured in hours. No, it's measured in minutes. And for each input, there's sometimes two outputs. No, this one is a function. All right. It costs $3 per hour to walk in a parking lot with a maximum cost of $12. So this is that same scenario from up above. Explain why the amount of time a car is parked is not a function of the parking cost. So this is where we're switching it around and we're talking about the cost. Like if I said $12 was the input cost, I could say the car was parked for maybe 8 hours. But since there's a maximum cost, I could also say $12 went with 10 hours or $12 went with 24 hours. Like literally there's a maximum cost and you could get all these different outputs for 12. So because of that, it is not a function. Does that make sense? Again, what's that true definition of a function? The relationship is not a function if for each input there are multiple possible outputs. Okay, here we are with these little riddles and clues for involving two numbers. 7 times the first number plus 6 times the second number equals 31. 3 times the first number minus 10 times the second number is 29. And what are the two numbers? So you just need to pause the video and try to solve this system. Let's see how you did. If I go times each other, times 7 and times 3, oops, how about I use the right one? All right, so we're going to go times 3 to the top and times -7 to the bottom so that we get an opposite here. So we're going to get, and by the way, we're probably going to need a calculator here, these numbers at the end. So 3 times 6 is 18y. Let me grab my little calculator. 31 times 3. All right, I'm getting 93. And then -21x minus 70y, 29 times -7. All right, oops, and do you see my issue with the sign right there? So -21, positive 70, -203. So these are going to cross out. 70 and 18 makes 88. And -203 plus 93. Getting -110. Divide by 88. I'm getting that y equals -1.25. And then when you plug that into any of the equations to solve for x, you can pick which equation you want to do, but let's say we chose 3x minus 10y equals 29. And 10 times 1.25, can you do that one in your head? You got it. It's 12.5 and made times a negative is a positive. 29 minus 12.5 is 16.5 divided by 3. I got 5.5. How about you? Okay, so my coordinates go together for the solution to my system, 5.5 comma negative 1.25. How'd you do? For number 6, it's bringing us back to statistics from Unit 1, and we have to remember the little formula for IQR. So to keep privacy about the students, a professor releases only a summary statistics about student scores from a difficult quiz. And here's the summary statistics they released. Based on this information, what do we know about outliers? So to do the IQR, we've got to take the Q3 and minus the Q1. And so 76 minus 57 is 19. So Q1 minus 1.5 times 19. And then we're going to do Q3 plus 1.5 times 19. And so let's grab our calculators and do that. And then 76 plus 28.5. And we're getting 104.5. So we're looking to see, do we have any data below the lower cutoff? And do we have any data above the upper cutoff? So our minimum, 12, is below the cutoff, but our maximum is not. So the correct answer here, what do you think? You got it. There is an outlier at the lower end of the data, but that there is not an outlier at the upper. And when it says there's not enough information to determine, well, you have to use the calculations. Do you see how at the beginning you might have thought there was an outlier at both sides, but by doing the math, we realized there wasn't? Now, number 7, I'm just going to briefly go over the answer, but this is the unit 3 that we at this time skipped. And so I'll just go over this and then we'll give you a little bit of background on it, but we are going to go to unit 3 in the future. But not at this time. So an airline company creates a scatter plot showing the relationship between the number of flights and the average distance in mile travelers drive to reach the airport. The correlation coefficient of the line of best fit is negative 0.52. Are they correlated? Explain your reasoning. And so a correlation coefficient of negative 0.52 means that they are moderately correlated. And that's because the correlation coefficient is not close to -1. When an airport's offered number of flights increase, the average distance in miles must drive to reach the airport decreases. And then part B, do either of the variables cause the other to change? Explain your reasoning. It is unlikely that the number of flights offered causes the average distance that the travelers must drive to decrease. Offering more flights does not change where people live. When people live closer to the airport, that doesn't necessarily mean they're going to offer more flights from the airport. So it is unlikely that the number of flights offered causes the average distance to decrease. Okay, and that is it for this practice problems.